Theorem: if M is a non-empty subset of a Hilbert space H, show that M perpendicular is a closed linear subspace of H. Proof: by the definition of M perpendicular equals to X belongs to H such that xy equals to 0 for all values of y belongs to M. Since 0 and y equals to 0 for all values of y belong to M, therefore at least 0 belongs to M perpendicular. Thus M perpendicular is non-empty. X1 and x2 belongs to, let x1 and x2 belongs to M perpendicular, and let alpha and beta be any two scalars, then x1y equals to 0 for all values of y belongs to M, and x2y equals to 0 for all values of y belongs to M. Alpha x1 plus beta x2 and y equals to alpha x1 y plus beta x2 and y, which equals to alpha into 0 plus beta into 0 equals to 0 for all values of y belongs to M. Therefore alpha x1 plus beta x2 belongs to M perpendicular, hence M perpendicular is a subspace of H. Now we shall show that M perpendicular is closed subset of H. For this we must show that if X is any limit point of M perpendicular, then X belongs to M perpendicular. Since X is a limit point of M perpendicular, then there exists a sequence Xn in M perpendicular such that Xn tends to X. Now let y belongs to M. Since Xn belongs to M perpendicular for all values of n, therefore we have Xn y equals to 0 for all values of y, which implies limit xn y equals to 0, which implies limit xn y equals to 0, because the inner product is continuous mapping and limit xn tends to xn equals to x, which implies x and y equals to 0. Thus if x is a limit point of M perpendicular, then xy equals to 0 for all values of y belongs to M. Hence M perpendicular is closed subset of H.